Welcome and thank you for joining the NEHA National Webinar Series. Today we're going to look at how food soils can remain undetected on dishes, glasses, utensils, and equipment, rendering sanitizers ineffective to kill pathogens to safe levels, and how best to achieve the sanitation goals of the food code through better cleaning. I'm Christy Denbrock, Chief Learning Officer at NEHA, and I will be your moderator. Our presenter today is Dr. Juan Goncalves. Juan is a scientific information manager and senior scientist at Procter & Gamble Professional in Cincinnati, Ohio. He has over 15 years of experience in the areas of formulation of cleaners and disinfectants, infection control, and food safety for retail and institutional application. Juan holds a PhD from the University of Cincinnati, an MBA from Indiana University, as well as CPFS and SafeServe certifications. We ask that you please write your questions into the chat box and we will address them at the end of the presentation. If you are not a NEHA member and you enjoy this session, we invite you to become one at neha.org. Juan, let's just get right into your presentation, and thank you for being here.
Thank you, Christian. Thank you, Neha. Thumbs up if you can hear me. Can you hear me? Okay, perfect. All right, so thank you very much. Again, thank you, Christian. Thank you, Neha, for the invite. We have a packed agenda today. Welcome, everybody, and thank you for joining this webinar. I'm going to switch here to my screen so I can share the deck. All right. Okay. So here's the webinar that we have for today, and I'm going to start by giving a shout out to all of the workers that are doing dishes in the restaurants, right? It's a tough job, even though our model there seems like it's having a lot of fun doing it. Fun fact, a lot of very successful entrepreneurs in the restaurant industry start as dishwashers. So it's like an entry-level job for many people in the industry. All right, so what's in the agenda for today? First of all, we're going to talk about the problem, okay? Is cleaning surfaces a tension among retail food establishment managers? If not, why, right? We're going to talk about scientific evidence that shows that food soils actually inhibit or interfere with the antimicrobial effect of sanitizers or disinfectants. And also scientific evidence that by not cleaning properly, there's a public health outcome that's adverse, which is the transmission of foodborne illnesses. We're going to talk about how a crowded marketplace with cleaning products and challenges in the implementation of cleaning procedures affect the performance or affect the goals of the food code when it comes to sanitation and also food ingredients. So that also affects as external factors that affect the performance of the cleaning protocols in a food service establishment. And finally, we're going to talk about how inspectors, so all of you in the audience, can actually move the needle and improve health outcomes in food establishments by being the spokespeople for what you're going to learn today. Okay. So let's start off with the what I call the State of the Union when it comes in cleaning compliance in retail food establishments. So we're going to frame up the problem here to begin. And what you see here is the hardcover of two reports from the FDA. This is a multi-year effort by the FDA where they set out to inspect, so to speak, restaurants or food service establishments, so full-service restaurants, quick service restaurants in delis. Again, a multi-year effort. They sent trained surveyors to inspect around 400 restaurants of each of these categories. And basically, they were trying to quantify the occurrence of risk factors that have been identified by the CDC as factors that affect the transmission of foodborne illnesses in these establishments. And the risk factors are bucketed into a handful of categories, most notably personal hygiene, avoiding cross-contamination of food contact surfaces or food, and also things like temperature and time of use, or cooking or holding food at the right temperature, and sourcing food from the right vendors. Okay. And what they determined was that based on the observations of these FDA surveyors, that up to almost 60% of full service restaurants show an occurrence of a gap in terms of cleaning or sanitizing properly food contact surfaces, which is a specific risk factor that we're going to talk about today. Okay, so the numbers are pretty high. As you see, there is a huge opportunity for improvement. The number one not compliant risk factor in this report was associated with time and temperature of use, specifically not refrigerating foods at the right temperature when they should have been refrigerated. But of course, not cleaning food contact surfaces properly or sanitizing them properly was also a huge risk factor that was seen to occur very frequently. As you can tell, there almost 60% for full service restaurants. Okay. This is an excerpt of the inspection template that the surveyors used. And what I want to mention here is that they had to observe a pattern before calling this risk factor out of compliance in the establishment. So in other words, if there was a pattern of not cleaning surfaces properly or not sanitizing them properly, then they were called out as a non-compliant. If it was a one-off, they probably were leaning and said, okay, that's not an issue here. So more likely than not, those numbers that we saw, 57%, for example, could be higher. Okay. So we know there's a huge opportunity for improving the compliance when it comes to cleaning food contact surfaces in food establishments. The question here is that an issue for the restaurant or the food establishment operators, right? Is that something that's in their mind as a tension, something that they have to take care of, okay? And the reality is that that's not something that's necessarily in their mind. This is a survey from the NRA on the state of the restaurant industry. And what you can see here is that regardless of the type of restaurant or retail food establishment here, the top three, well, actually the top five items that were self-identified as challenges by these operators had to do with turning a profit. Okay, so food cost, inflation, labor cost, labor staffing shortages as well, the economy, energy costs, and so forth. So what this is telling us is that cleaning is not the most important thing that is in the mind of the operators in terms of things that they have to look after or comply with, right? So these people are pretty much trying to turn a profit, rightfully so. Okay, so let's keep that in mind for a minute and talk about whether that profit, making a profit oriented goal uh, moves the needle in terms of cleaning. So is cleaning something that the retail food establishment manager should be concerned about? Okay, and the answer is yes, even not only from the standpoint of preventing the transmission of foodborne illnesses, but also turning a profit, if that's the angle that needs to be utilized to influence them into cleaning better. Okay, so this is a manuscript, a paper that was published around 20 years ago on the Quarterly Journal of Economics from this is a professor from Stanford and another one from Maryland, University of Maryland. So what they determined was that in LA County, in Los Angeles in 1998, restaurants were mandated to display the scorecards of inspections at the door, and they wanted to study how that influenced the demand for services from these restaurants. and also the compliance or the scores moving forward once the scores have been already published and shown to the public. And what they found is that based on the publication of these cards, the restaurant health inspection scores increased over time. But importantly, the consumer demand became sensitive to changes in restaurant hygiene quality. In other words, the better the scores, the more consumer demand for eating out of the restaurant. Okay. And of course, the number of foodborne illness hospitalizations decreased, which is the goal of the sanitation, right? So, in other words, the great cards cause restaurants to make hygiene quality improvements, but again, consumer demand increases. So, an angle that could be used to amplify the importance of cleaning. If you are a restaurant manager that's really concerned about turning the profit in your operation, particularly nowadays, that's very expensive, and you have concerns about food costs and inflation. Okay. Another study from the American Journal of Public Health. These are a few folks from the Department of Health of New York City. They conducted a similar study than the one that was published 20 years ago. And basically, in New York City, what they found is that, um, again, from the moment that they started publicizing the scores at the restaurants, the inspection scores, the sanitary conditions of the restaurants improved. And they also found from the research that, in case of New York City specifically, anyways, the New Yorkers, almost 90% of them consider the scores as dining decisions, right? So in other words, if you have a good score, it's more likely that your restaurant it's gonna have a much higher foot traffic in it. Okay. All right. So with that in mind, so let's keep in mind again the issue of there's a huge outage in terms of compliance with cleaning food contact surfaces, as determined by the FDA surveyors, and that the restaurant operators don't necessarily have that in mind as a top priority. Okay, so let's put those thoughts in the back burner because we're going to come back to them. And right now, jump into the meat of the presentation, which is the science behind how food soils interfere with sanitizers. All right, so what I'm going to show you here is four peer-reviewed publications. These are academic researchers that conduct experiments under controlled conditions. So imagine somebody in a microbiology lab with a lab coat, and what they're doing is they're determining the effect of food soils on chemical sanitizers and how that food soils interfere with the effectiveness of the sanitizer. Okay, so this is scientific evidence that the food soils actually affect the performance of the antimicrobials upon the bacteria that we're trying to sanitize. So the first study comes out of Japan in the Food Science and Technology Journal. Basically, what these individuals did was they used food residues, so milk, beef gravy, and tuna gravy, and they measure how the food soils affected the efficacy of benzalkonium chloride, which is a first generation quad, widely used in the industry for sanitization. And another antimicrobial that's not used in the US, but nonetheless, they tested that in their experiment. And they tested that effect of the food soils on organisms like E. coli, Pseudomonas aeruginosa, Staph aureus, and Bacillus cereus. Okay. What they found is that the food soils actually protect the bacteria from dehydration. Okay, so allows them to survive more on environmental surfaces. Okay, and it also protects the bacteria from being killed by the sanitizer. And they also found that after washing those food residues upon the surfaces where they were testing the effect of the food residues on the bacteria, that actually the antimicrobial used, the benzalkonium chloride and the other ingredient, became efficacious again. Okay, so again, this is an experiment under controlled conditions in the lab that shows the effect of food soils interfering with antimicrobial ingredients. Similar study, in this case from the journal Antimicrobial Chemotherapy, also from Japan. So this individual studied specifically the interference of organic soils on benzalkonium chloride, again, a quad, on Acinetobacter bacteria. Now, rather than using food soils specifically, They use something called bovine serum albumin, which is a organic material that's used in labs for microbiology research. It comes from cattle, right? That's the bovine name right there, and basically it's used to determine the effect of organic soil on the performance of antimicrobials. Okay, and what they found is that when they uh, treat this bacteria with 100 ppms of the quad solution, the performance, the efficacy of this quad decreases by 100 times when the bacteria is in presence of a 3% solution of that organic soil BSA after 1 minute of treatment. Okay, so if you want to see this in a more simplified way, imagine that you have 100 microbes in your surface, and now you have organic soil from the BSA, and now you're antimicrobial. Instead of killing all 100 organisms, killing only one of them. So your efficacy decreased by 100 times. Okay, even after 10 minutes of treatment, which is not something that's allowable for a sanitizer, which is only contact time of 1 minute, the antimicrobial could reach the efficacy of a clean condition. In other words, the BSA presence in organic soil prevented the 200 ppm solution of quad to be efficacious against the Acinetobacter even after 10 minutes of contact time. Okay. Here's another study. Now we're going to switch to chlorine as the antimicrobial ingredient here. It's pretty old, from 1979. Yep, 1979. So this is something that's been understood for quite a while. Okay. And what the researchers did here is that they took solutions of 125 ppms of chlorine, and they determined what was the effect upon killing E. coli when the solution was contaminated with food soils, in this case, milk. Okay, so the first thing that they found is that the chlorine pretty much 2/3 of it disappears or gets quenched or reacts because of the presence of milk. So chlorine is very non-selective and goes after all organic materials that it could affect. So just the presence of 1% quantity of milk in the media reduced the available chlorine that was left to go after the bacteria. Okay, and here's the consequence of that. So you have your 125 ppms of available chlorine. You put 1% of milk as a contaminant or food soil, and your E. coli efficacy decreased 100 times. And when the concentration of milk is doubled to 2%, it's 100 million times. Okay, so in other words, in this particular experiment, the 2% concentration of milk made 100 million microbes that would have otherwise been killed, pretty much let them survive. Okay, so that's a very dramatic effect in terms of interference of food soil with an antimicrobial. And again, bleach is very non-selective, so it's one of the ingredients that suffer the most from the presence of contamination. Okay, they also did some experiments with what's a powder or solid chlorine solution that's like chlor. Those are the little pouches that you've seen in restaurants or sinks, where you pretty much open the pouch and dissolve the product, and then you have your chlorine solution there. But nonetheless, also affected by the presence of food soils. Right? And the last publication here from the Journal of Hospital Infection, this is another publication. And now we're going to talk of a different ingredient, which is hydrogen peroxide and peracetic acid. It's not used in kitchens, for example, for sanitization, but it's a popular disinfectant for, say, healthcare facilities or food manufacturing. Okay, and this is a report that comes from a researcher group in Australia. And what they found is that 2,000, more than 2,000 ppm of peracetic acid, a very aggressive antimicrobial ingredient, when was tested against specifically Staph aureus as the organism, that efficacy of the peracetic acid reduced or decreased by 1,000,000 times by the presence of BCS, so the bovine cough serum, similar to the BSA that we had talked about before. And again, another organic soil that's used in microbiology labs for research. Basically, organic soil, again, the takeaway is that the organic soil, the BCS, was used at high concentration as an interference substance, and the peracetic acid efficacy decreased by 1 million times on a suspension of stop worries. Okay, on a biofilm, which is a different type of environment where the bacteria live, the efficacy was also affected by 100 times. The reason the number is less than a suspended solution is because biofilms are very difficult to kill nonetheless. So the number was low to begin with. Okay, and that's basically the conclusion here. So these are four peer-reviewed manuscripts where they have benchtop experimental data, and they show that quats, bleach, and peracetic acid are affected by the presence of organic material or food soils. So this is clear evidence that these substances interfere with the efficacy of the antimicrobials. And this is only four experiments or four reports, but there's hundreds of these. And most of them are coming actually from healthcare industry or sector because there's more visibility to the issues over there in terms of healthcare acquired infections. Okay. So what happens now with sanitization that doesn't rely on chemical uh, efficacy, but actual heat, right? So mechanical or washing machine, you have water there. That's your sanitization step. Well, if you have food soils on the surface, what's going to happen is that the food soils are going to act as insulators of the hot water. Okay. So what we have here is a table that shows a heat conductivity coefficient of these materials here. Heat conductivity coefficient is basically a property or a thermodynamic property that describes the ability of a body to transmit heat across it. Okay. And let's not be concerned about the concept itself, rather than the fact that when you look at the numbers that are shown there in the column and the second column, you see copper, for example, you have a number that goes up to 394, and that's watts per meter Kelvin, which is a unit this thing is measured in. So it's a pretty high number compared to the rest of the other materials, and that's why copper is very good heat conductor, and it's used in radiators and heat exchangers, right? Now, when you look at things like proteins, fats, or carbohydrates, the numbers are significantly low compared to the metals, right? Aluminum or copper, especially fat. So fat is several times less heat conductive than copper. What this means is that if you have a food contact surface that's covered in fat or proteins or carbohydrates, in other words, food soils, then these are going to act as insulators, and your hot water is not going to kill the bacteria that you're trying to kill on those surfaces. Even if you have a irreversible register that runs through the machine and comes out at 160 degrees, that hot water probably never allow the surface to reach the right temperature because of the presence of the food soils. Okay, so chemical sanitization gets inhibited by the presence of food soils, and the same thing happened with thermal sanitization. Okay. All right, so that's what happens in the field, in the lab. Okay. Now let's go to the field. Let's go to the practical application of the situation. So what happens in actual restaurants? When there's improper cleaning of food contact surfaces, right? And if you see the picture there, that's water in a dishwasher. That's a really bad situation that you have there. Obviously, if you haven't noticed. Okay, so according to the CDC, and this is epidemiological data, right? So about 70% of outbreaks occur at restaurants. And when it comes to evaluating the actual reason why the outbreak occurred, remember that the FDA had already evaluated the occurrence of risk factors. So we have things like poor personal hygiene are responsible for some of these outbreaks. Also, preventing cross contamination of food, among other through improper cleaning or sanitization of food contact surfaces. And there's other things like inappropriate time temperature control, or getting food from unapproved sources, right? So when it comes to the actual linkage between the risk factor and the outbreak or the disease, we have to get into the epidemiology of the outbreak. And there's a seminal study from a group out of Michigan State University. So this was a study that was commissioned by the International Association of Food Protection. And basically, what this group did was they reviewed a database of around 800 outbreaks that were publicly available, not only in the US, but also other countries in Europe as well. And they analyzed those outbreaks that had enough epidemiological evidence to link a risk factor to the actual outbreak of the foodborne. And what they found is that out of the 816 reported foodborne outbreaks, 21 of them were caused by inadequate cleaning of food contact surfaces, right? Which led to contamination of the food, right? And the causative agent of those 21 outbreaks was primarily norovirus and Salmonella enterica. Interestingly enough, the vast majority of those outbreaks, of the 816 outbreaks there, were linked to improper personal hygiene. In other words, things like employees showing up to work sick, or touching food with their hands, or not washing your hands when you should have done that. Okay, so but also the time and temperature abuse, just like the report from the FDA that found that was the most important outage there. That was also a contributing factor here, but personal hygiene was the number one from an epidemiological standpoint. Okay. All right. So we know that there's an opportunity for improvement when it comes to compliance with the cleaning food contact surfaces. And we know that there's epidemiological evidence that not cleaning leads to outbreaks, right? So what tools we have at our disposal, right? So this is where products and procedures for cleaning, um, you know, play a role in terms of improving sanitation outcomes. Okay, so let's talk about the theory, right? So what you see here is again the hardcover of the latest edition of the Food Code. There's also cover of other position documents by the Conference of Food Protection. If you're not familiar, the Conference for Food Protection is a collaborative, is a non-for-profit organization that brings together stakeholders in the industry that may affect or are affected by regulatory decisions that pertain to food safety, right? And these two documents establish guidelines as to what are the sanitation goals that should be achievable in food service establishments, right? So when it comes, for example, to food contact surfaces or non-food contact surfaces, the goal is to clean surfaces to the side and touch. Okay, so that's what's highlighted there. Also, the food contact surfaces should be free of encrusted grease deposits and other soil. And when it comes to non-food contact surfaces, they should be kept free of accumulation of dirt that may bring pests, right? It may attract pests into the operation. So those are the sanitation goals of the food code. Okay. When it comes to wet cleaning, and this is also from the food code, and wet cleaning is where most of the restaurants, the method that most of the restaurants do the cleaning. Things like bakeries, they have to do something different, dry cleaning, but that's for out of the scope of this presentation. But when it comes to wet cleaning, again, so the food contact surfaces uh, should be washed to remove or completely loosen the soils, right? And that's achieved by using the manual or mechanical means necessary, right? So products, procedures, tools, okay? And it said here that the washing procedure should be tailored to the type of soil to be removed. And that's going to be a factor we're going to talk about later because that complicates what the product and procedure is, okay? As far as the Conference for Food Protection is concerned, they also have a position about cleaning and cleaners, okay? So they're saying here that the cleaning formulation matters, um, as well as the conditions it's going to be used, and the procedures and the cleaning products should be tailored to the type of soils. In this regard, the two documents are very similar in terms of intent. Okay. Now, the problem with this is that when it comes to the practical aspect, there's no regulatory standard for performance when it comes to cleaning, at least on environmental surfaces of the kinds that are encountered in restaurants, right? And this is a comment from one of the individuals that presented in a conference for International Association for Food Protection in 2022 from the FDA. And you can read this because of the variety of cleaning agents as well as the various types of soils and situations. It's not really possible for us to recommend one solution that's going to be effective in all circumstances. What this means is that the burden of cleaning and determining when something is clean now relies on the end user and the trust they have in the products that they're using, the tools that they're using, and whether the cleaning products or the tools are appropriate. Okay, and that's a problem. And here's a demonstration as to why. Okay, what you see here is a demo where dishes were covered with a greasy residue, and there's a color, food color dye that likes the greasy residue. So in the first column, the first plate in the top left there was cleaned with a detergent. Let's call it detergent A, and the product next to it was cleaned with detergent B. Then on the second row there, what you see is the end result of that. So the two products look clean to the side. Okay. However, when you add more of the red dye, that again likes or is attracted by the greasy residue, you have more indicator or red dye sticking to the surface, which means that even though the surface looked clean, it wasn't really clean because there was invisible greasy soil left on the surface. Okay. And you may not see it there, but on product A at the bottom, there's some speckles of red dye around the edges of the bottom of the plate. Nonetheless, there's a huge performance difference between the two products, and compared to the second row, that again surfaces that look clean to the side, they were not really clean, as it can be seen by the demo here. Okay. The other sensory aspect of the success criteria, which is clean to the side and touch, is that you may go back and touch the surface, and I guess the purpose would be to hear, I don't know, like a squeaky clean sound or feel. But when you're doing that, you might be reintroducing germs to the surface, right? So clean to the side and touch has some practical limitations. Okay. Here's another example. This was presented from Ron Masters and Christopher Lynch from Stepan at the International Association for Food Protection in a year ago, sorry. And basically they showed a demo, it's a video, but it's not gonna play here, where they're cleaning two surfaces that were contaminated with grease, and they look clean to the side. However, they are not necessarily clean. And the visualization for that is they pour water onto the surface. If the water creates like a fine sheet of thin water layer on the surface, it means that the surface is clean. If it beads out, then it means that the surface is greasy. Okay, so greasy doesn't like water. Therefore, the water doesn't sheet; it creates beads. Okay, and this is the result of the demo. Okay, so on the left hand side, you have two surfaces that were clean, contaminated with asymptotic fatty residue. On the right hand side, one of them was cleaned with a sanitizer, and the other one was cleaned with a proper degreaser. So they both look clean. However, the surface that was cleaned with a sanitizer is not clean. It's clean to the side, but it's not clean because the water beats out on the surface. Okay, so that surface there is not ready for sanitization. Okay, remember, sanitizers get inhibited by the presence of food soils, or in this case, organic material. Okay. Um, This is another demo, and it's a video, but I'm not going to play it. I'm just going to show the beginning of the end of it. But to set the stage properly here, what you see there is a slab that's contaminated with a very sticky food residue. It's basically a vegetable oil that's cooked on the surface, and it's got some uh, proteins and starches and other ingredients there that simulates a heavy soil encountered in commercial kitchens. Okay, so there's four sponges there. The sponges are soaked in different chemicals, water for control. In this case, we have detergent, and we also have a food contact cleaner and sanitizer. Okay, the sponges go back and forth, and they have a little weight on the top that is the same across all the four sponges. And what it does is creating the same pressure on the sponge onto the slab. Okay, so you activate, initiate the machine. The sponges go back and forth several times. And what you see here is that after around, this is 8, 10 strokes, the surface that was clean with the detergent looks clean. However, the surface that was clean with the food contact cleaner and sanitizer is just as clean as water. Okay, and this experiment can be repeated, changing the position of the cleaners and doing this several times, and the result is the same. Okay, now this is not to say that a food contact cleaner and sanitizer doesn't clean. It's registered to be a cleaner and sanitizer. Okay. The problem is when you have visible soils like this or gross soils like this, then you have to pre-clean surfaces for sanitizers or disinfectants to be effective. Okay. And the products may not be effective depending upon which one you use to clean heavily soiled surfaces like this. Okay. So formulation matters. And for those that think that a food contact cleaner and sanitizer is the perfect solution for an operation, it works if it's a lightly soiled surface. That's perfectly fine, but it's not going to work everywhere. Okay. So here's part of the reason as to why a product like a food contact cleaner and sanitizer may not work really well for heavily soiled surfaces. That has to do with the type of soil that you're trying to clean. And when it comes to a formulation, what are the ingredients that really are effective at cleaning those soils? Okay. So depending upon the soil, whether it's an animal fat or some plant-based oil, starch, protein, pigments, right, cocoa, oil and particulate, the ingredients that are key in removing them from the surface are different. So these are on the top row there, you have surfactants, solvents, builders. These are ingredients that you typically find in a clean formulation. They are not all necessarily compatible with each other. So there's always a trade-off that needs to be made when it comes to the formulation. And that's why a multi-purpose cleaner will be effective at cleaning a variety of soils, but not necessarily with the same efficacy of them. Okay, so there's always a trade-off. When it comes to a food contact cleaner and sanitizer or a food contact sanitizer, the universe of ingredients that you can utilize to formulate the product or the level at which you have that ingredient in the formula. So the percent, the concentration of that ingredient in the formula is limited, okay? Because you're gonna leave the product on a plate, you're gonna eat off of, right? And the trade-off there is that it may not be effective by making it safe to the point that it's there on the surface of your plate. It may not be necessarily very effective against tough soils, right? Like the one that I showed prior. So those are the trade-offs that need to be considered. Okay. Of course, the best formulated products are not going to work if you don't have the proper procedure. Okay. So this is an example of a procedure that was customized to achieve better results when it comes to cleaning. What you see there are two cutting boards on the sides of the table in the middle. So these cutting boards have been cleaned. in a normal, manual wash operation in a three compartment sink. So detergent, water rinse, and sanitizer. The one in the middle actually was changed and to include the addition of bleach, disinfectant, or the bleach product there to clean and bleach out the soils that remain there, that linger there. Okay, so again, a customization of a procedure that leverages products that can achieve better results in terms of cleaning compliance, from going from a manual wash in three compartment sink to the addition of a bleaching agent and the right tools, in this case, a wire brush. Okay. Another example of procedures that are tailored to the particular operation that leads to better cleaning outcomes is, for example, the addition of a anti stick coating into a grill. Okay, so this product will prevent, it's not going to prevent the deposition of calcinated food soils from the grill, but it's going to make easier the next time around that the grill needs to be cleaned to remove those soils, right? And there's also there some pictures that depict the proper tools that need to be used. For example, a wire brush and a paint scraper here. Okay. One that I found also very interesting is a procedure that allows for better quantification of the quad concentration in a tank where you have your sanitizer. This was a test where around 30 people were asked to quantify the concentration of a standardized solution up to 100 ppm of quad using the typical paper strip. And you have the numbers were all over the place, as you can tell there. Okay, so the procedure for measuring, quantifying the quad level in the tank was modified from just dipping the paper strip into the sanitizing solution for 10 seconds, and then comparing that versus uh, the package that has a scale there. The procedure was changed to accommodate for what happens in the field and reduce those error factors, right? So take a little sample of the formula, make sure that there's no foam or suds on the top of the sanitizer solution. Let it sit for a while so that it reaches the proper temperature. Take a particular amount of paper strip, and if it's coming in one of those coils where you have an adhesive that's sealing the beginning of the coil, you have to discard that because that adhesive is going to make the reading inaccurate. Inserting the paper strip in the solution without moving it, okay, taking it out without shaking it, and then comparing to the scale there. That leads to more accurate results. Again, so another procedure that was tailored for the specific circumstance to achieve better control in cleaning outcomes in this case. And of course, I mean, something that really works well per feedback from people that are involved in this is the leveraging visual procedures, right? So this is a very simple manual wash process where you have your wash and rinse and sanitization, three compartment sink. And if you're like me or like many people nowadays that they prefer to just see something happening versus reading a label or reading a paper or a wall on the chart with a procedure, then this is very effective as well. Okay. What about non-food contact surfaces? So remember, the food code talks about cleaning non-food contact surfaces. So your, say, floors, for example, to prevent the accumulation of dirt so that you avoid the risk of pests from coming into the operation. We would argue that that also helps not only in terms of better outcomes from the standpoint of food safety, but also the safety of the workers. That's not related to food, right? It's more like OSHA um, sort of safety indicator. So, for example, if you have the wrong floor cleaner and you have a floor that's very greasy, then you're going to make a floor that's probably going to be slippery, okay, and not clean. And if you don't have the right product, and that's an extreme case, so sorry for that, that you're going to use for a fume hood to properly degrease very heavily soiled, sticky soil from the fume hood filters, then you may risk you have the risk of potentially a fire happening in this operation. Which my understanding is that some restaurants have been burned to the ground because they catch fire in the fume hood because of the accumulation of oils. Okay. Okay, something that affects the efficacy or the outcome of the sanitation procedures or practices in the operation is changes in ingredients. Okay, and some of these are not controlled by the operators, right? So this is a typical example. Back in the day, um, you know, uh, 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 cooking was done with lard. And the problem with that is that this product had a very short shelf life, spoils very quickly. So one of the solutions to this was to hydrogenate plant-based oils, right? And that created something that's similar to what's shown here in the middle of the presentation. So this was a product that had the field taste of lard, but without the issues with the shelf life. The problem is that these are trans fats, and they were banned by the FDA because of their association with coronary heart disease and coronary artery disease and health issues, right? So the hydrogenation of plant-based oils was forbidden from resulting in a product that could be used in kitchens. So we went back to using plant-based oils. Okay, and that would be soybean oil right there, that's shown in the picture. The issue with that is that plant-based oils, which I think are used in almost every single in a restaurant where there's some frying or deep frying operation, is that these oils react with the heat of the cooking process, and they create a hardened coat on the surface, right? So if you imagine a floor finish on a shopping mall that's very shiny, that starts with just a liquid product that's being mopped on the floor, and then it cures and creates this hardened layer there. Something similar to that happens with the plant-based oils. Okay, this is very difficult to clean, to the point that a typical oven grill cleaner, it will be very effective against animal fats like lard. Doesn't really do much for this kind of residues here. So products need to be formulated to be effective against this type of residue, which is very typical in restaurants in back of the house. Okay. So again, one example of how changes in ingredients affect inadvertently the performance of your cleaning operation, and requires a change in products or procedures, right? Okay, so we talked about products, procedures. Let's talk a little bit about the culture of implementation. Okay, so again, let's go back to this to technical reports here about the risk factors that were observed in the food establishments that were surveyed by the FDA individuals. And when it comes to food safety management systems, what they found in the report is that those establishments that had the fewest amount of out of compliance issues were those that had strong, robust food safety management systems. So, for example, your typical HACCP, right? So your hazard analysis and critical control points, that was associated strongly with compliance, right? So that's really important consideration for ensuring success of the sanitation goals of the food code. Okay, again, well-developed food safety management systems. Okay, there was a predictor of compliance with the risk factors that were surveyed in the reports. The results were similar regardless of the operations. In other words, whether it was a quick service restaurant, full service restaurant, or a deli, having a strong, robust food safety management system correlated with better outcomes when it comes to managing the food safety, the risk factors that were surveyed by the FDA individuals. And of course, you may have a perfect plan, But if you don't validate the plan, monitor and enforce and correct, then it's not going to work, right? So that's basically the recommendation. That's when it comes to culture and implementation. Okay. So take some lessons, and with this, I'm going to finish. Number one, lingering food soils, invisible or not, impair the sanitation goals of the food code because they inhibit the efficacy of chemical or thermal sanitizers. Cleaning agents differ widely in composition. I showed a table that has the different ingredients, how they are more effective versus certain food soils than others. Um, there's a wide variety of formulations out there. I also showed differences between two products when it comes to cleaning, the red greasy soil and also the sponge demo as well. Procedures are key. Okay, they should be again a perfect cleaning product that works really well in the lab. It's not going to do anything if it's not used properly in the field. So you need the right procedures. That includes the tools as well and how to clean surfaces, right? And ideally procedures that are clearly communicated. So the procedures that I showed are very rely a lot on visuals and pictures because nobody likes to read, very wordy labels. Okay. Coming back to the business results, I told you to keep this in mind. If the establishment managers are not really concerned about cleaning, and that's a chore that they just must do. A way to communicate this is that a better cleaning, um, um, more compliance with the cleaning goals or the sanitation goals of the food code translates in better scores, and that translates in more for traffic into the store, into the restaurant, if that's the angle they want to connect with. Um, Also, they have a vested interest in using right products, cleaning products, and procedures because not only are they going to reduce the likelihood of a outbreak from happening in their store, not only are they going to have better score that they can display and potentially increase foot traffic, but they're also going to waste less time and resources in terms of rewashing, for example, or training people on how to utilize a product that doesn't work or it's not easy to work, and also the cost of labor by rewashing, right? So the cost of availabilities. And the last one, a very important one, is that the health inspectors, and that's all of you. You can be a strong voice advocating for this, right? So I can go and visit 600,000 restaurants in the country, but you guys go there all the time. And you can ascertain whether something is properly clean or not. So be the advocates of the need for a better more compliance with the proper cleaning of food contact surface and not based on what you've said, what you've seen today, and uh, don't over focus on the a food contact sanitizer having the right concentration if the kitchen is dirty. Because as we showed today, the food soils are not gonna, pretty much going to render the sanitizer non-effective. Okay, so we have to be better advocates in terms of the cleaning outcomes and cleaning surfaces properly, not just the sanitization part of it. Okay. More information in this article. This is an op-ed that was published in the Environmental Health Journal of Environmental Health of NIHA in May of this year. And there's some additional comments there. That's my email there if you want to reach out. And with that, I'm going to stop now and leave it for comments.
Okay, Juan, thank you so much for that. We have quite a few questions that came in, as well as one of our first questions is, would you be willing to share your PowerPoint deck with the attendees? You could send that to me and then we could
Yeah,
send it out to the attendees.
yeah, absolutely. I just said
Wonderful.
I
Okay.
share, so yeah. Mhm.
We always ask, we just want to make sure copyright issues and all. So we will send that out to everyone.
Mhm.
One of the first questions we
Yeah.
received was, does lime scale have effect on sanitizer or heat efficiency?
That's a good question. So lamp scale has a very important effect on the efficacy of thermal sanitization for sure. Okay. So we have seen that places where there's a lot of hot water or the cleaners are not formulated to combat the presence of very high concentrations of hardness in the water, they end up like depositing a film of the heating on the heating elements of the machines, and with that, the machine needs to work harder to achieve the right temperature, or it doesn't do that, and then you end up, utilizing water that's not gonna let your surface achieve the right temperature. Okay. When it comes to lime scale in chemical sanitization, for example, something like a quad sanitizer on a tank on your third compartment sink, so water hardness does have an effect on quad sanitizers, and that's why the sanitizers that are mostly used nowadays are formulated to be effective in the presence of hot water. Okay. Typical concentrations of hot water is 200 ppm. I've seen 400 ppm, 500 ppm, right? But that will depend on how the product is registered. So you have to take a look at the label and see whether the concentration of quad that you're measuring with your paper strip matches the one recommended on the label per the hardness of the water that you have in your operation. Okay. But yeah, the absolutely the water hardness can affect chemical and thermal sanitization.
Okay, thank you. Let's move on. This question is, has any comparisons have been done between manual 3 compartment sink cleaning versus an automatic dishwasher?
Not that is publicly available, to my knowledge. So basically, the idea of choosing one or the other depends on whether the facility has a need for high throughput of cleaning. Okay. If you are a small operator, an independent restaurant owner, and there's not a lot of foot traffic in your operation, you might just be get by with the manual cleaning. Okay. So that's a minimum that you need to open your restaurant, right, or your operation. You have to have at least a sink where you're gonna do your clean, your wash, rinse, and sanitization. The mechanical where washing is an option, and again, you choose to do that or not, depending upon your needs. But as far as cleaning performance, um, I would say that machines that are NSF certified, they at least do one test where they have buttermilk residue on the wear, and that needs to be cleaned to the site. Okay. And that's one of the standard tests that they need to pass to get the NSF certification, right? When it comes to the manual washing and wear, as far as if it's efficacious or not, that's not really something that has been that we know there's public data with comparisons. I mean, we have our own studies done, which are not public information. And one of the things that we're trying to do is influence regulators to come up with some sort of a performance efficacy standard, so that we put to bed this whole situation of everybody calls themselves a cleaner, but when it comes to actually cleaning a surface, there's a lot of variability in terms of the performance. So there's no performance standard that allows you to compare uh, quantitatively, right? In a way that's widely accepted in the industry. Okay. One process or the other, and that's part of the problem.
Okay, I think we have time for one more quick question. The questions that we did not get to, we will send to Juan after this
Mhm.
presentation. He will answer those. And then when we send out the video recording, which will be up on our NEHA YouTube channel, the PowerPoint presentation, a quick survey, and we will also send you the answers to the questions we don't get to. So Juan, real quickly, one more question. At what point should a visibly soiled towel that has been in a detergent solution be discarded to prevent soil redeposition and cross-contamination?
So it's an interesting question. So right now, in the last conference for food protection, there was some attempt at changing the codified language around utilizing reusable wipes or cloths in this case for these purposes. So I'm not sure there's going to be consensus on this, but um, a a wiping cloth that's in a sanitizing solution should be discarded or washed every at least minimum 4 hours, and the concentration of the quad needs to be checked for the proper level. If it's visibly soiled, and again, that's a sensorial, very subjective assessment, then the solution needs to be dumped and the wipe needs to be rewashed. Now, the food code tells you that you have to wash your wiping cloths if they're reusable, but they don't necessarily say what constitutes clean, right? So you may just run those in your washing machine, whether you do it inside or in a contractor, and they come back to you and they were just running the washing machine. So there's no standard to determine whether that should be dumped or not. I would say that if it's visibly soiled and visibly dirty, then you have to discard it.
Okay, thank you. And unfortunately, that is all the time we have for today. We at NEHA would
Mhm.
like to thank Juan for sharing his expertise and the gift of his time. And of course, your feedback is very important to us, and we encourage you to fill out the survey. And that helps us to continue our mission to build, sustain, and empower an effective environmental workforce. Juan, again, thank you so much for your time. Thank you all for attending, and we wish you all a good rest of your day.
Thank you very much.
Thank you.